Okay, students, I'm going to do a video of your test key. Essentially, I'm going to take the test and my wife is going to film it while I do it. You need to remember that the second part of the test from problem number 12 on will be your retest. You're going to have a second chance at those problems if you so desire. So please be paying careful attention, and again, I'll work through it slowly for you. All right, using this graph here on number 1, we're supposed to tell whether the first and second derivative are positive, 0, or negative. First derivative, of course, is just the slope. So these points go in order, A, B, C, D. At A, the slope is positive because the graph is going uphill. At B, it's a maximum, so the tangent line would literally come straight across. It'd be horizontal, so the tangent line is a slope of 0. C is going downhill, so the slope would be negative. And D is a minimum. Again, the tangent line would be horizontal and have a slope of 0. All right, second derivative tells the concavity. Is it concave up or down? If it's up like a cup or a smile, it's positive. And if it's down like a frown, that means negative. So on this first point, this is definitely down like a frown. So that would be negative. B is also in the down like a frown part. C is where it changes over. I want you to notice that the second part would be up like a cup, right? So the concavity is positive, so D is definitely positive. But C is where it changes over from being negative to positive. That's the inflection point. So at that one point, the second derivative is 0 because it's neither concave up or down. Now on the next problem, I want you to notice that at 8, the function is 100, and the function is changing by 10. But that number itself is getting bigger, or at least not getting smaller, because it could be equal to 0. So which of these values could be true for the value at 9? Well, we started at 100, and then it went up by at least 10. So 110 would be the minimum value, but depending on how much that first derivative of 10 is increasing, because the second derivative is positive, it could be infinitely bigger, frankly, but no smaller than 110. So all of these, C, D, and E, would be possible values. All right, the next problem is somewhat similar. The cost of 100 items is $1,000. So the cost of 100 is 1,000. It's changing at 5. So approximate the value of the next item. Well, frankly, that would be 1,005. It's $1,000 to begin with. It went up by $5, so it'd be 1,005. The next one, the cost of 100 items is 5,000. The cost of 102 is 5,100. So obviously those extra 2 items cost $100. What is the marginal cost of the 100th item? What I'm really asking for is what's the derivative of C when Q equals 100? Well, if those extra items cost $100 and there were 2 of them, the best we can say is that the average was 50. So they're $50 a piece. So $50 would be the approximate value of the 100th item, or if you prefer, the increase at the 100th item. But at any rate, the next one, derivatives. Again, this first couple were supposed to be simple for you. Find the derivative. The derivative, again, is the slope. Well, this is a straight line. Slope is 5. The next one, the natural log of 4 is an actual value, folks. You can put that straight in your calculator. This would actually be a horizontal line, something like y equals, well, it's going to be 1 point something. So you're going to have a horizontal line, basically like that, the slope of which is 0. If it's a constant, the derivative is always 0 because it's a horizontal line. Okay, let's keep on going here. Number 7 is where it picked up difficulty for sure. You had to take this power on the denominator, move it up to the top. That means f of x equals 5x to the negative 2. Now to take the derivative, folks, you're going to take this negative 2. The easy thing to do is take our shortcut and multiply it times the 5. Which would give me negative 10, and this would be x to the negative 3. Now you're not allowed to leave this negative exponent. If you did do this, I gave you half credit because you did the calculus right, but to fix it completely, we'll need to take this and move it down to the bottom. So you have a negative 10 on the top, and when you move this x to the negative 3 to the bottom, it becomes an x to the positive 3. So the final answer would be negative 10 over x to the positive 3. The next one is a basic rule, folks. You just need to know this. The derivative of a to the anything is a to the anything times the natural log of a. So actually, that is the answer you need to have in the blank. All right, the next one's another rule again. The derivative of a natural log is, so the derivative of the natural log of anything is 1 over anything. This was the first place the chain rule came into effect, folks, because this was not just the natural log of x. It was the natural log of 2x. So you had to multiply times the derivative of what's inside. So you had to multiply by 2. This essentially means the 2's would cancel, and you'd be left with 1 over x. If you left it in this form, or 2 over 2x, again, your calculus was right, and I gave you half credit. All right, chain rule again, folks. E to the anything. The derivative of e to the anything is e to the anything. But again, folks, this wasn't just an x, it's a 5x. So you had to multiply times the derivative, so times 5. And of course, I like to put the coefficient out in front, and I would have written it this way. All right, one more chain rule. This is a simple power rule. 5 times something raised to a power. The simple way to take the derivative again is just take the 5 times the 4. You know what? This one might be a little bit harder, so let's just go ahead and take the 5 and set it off to the side. You can do that on every problem, and then merely take the derivative using the simple power rule, where you move the 4 down in front, then you have your parentheses, your 2x plus 7 to the 3, but then again you have to remember this wasn't just x to a power, it was 2x plus 7 to a power, so you have to take the derivative of what's inside. The derivative of 2x plus 7 would be 2. 5 times 4 times 2 would be 40. 2x plus 7 to the third. All right, now here we have an exponent rule. It doesn't look like it though. You have to remember how to convert these into powers. You always put power over root, so the f of x would be x to the 2/5. Using your simple power rule, the derivative, you move the 2/5 down in front, times x to the subtract 1 from the power. 1 would be 5 over 5 here, would give you a negative 3/5. All right, this is half credit, of course, for getting here. Now it gets a little bit complicated. We have a negative exponent and it's a fractional. Both of those are no-nos. Let's deal with the first thing first. We'll have to move this down to the bottom, which would leave us with a 2 on top, a 5 on the bottom, and of course this would become x to the positive 3/5. Once again, you're not allowed to leave that in fractional form, so we convert it back to radical. So this would be the 5th root of x to the 3rd power. And that's exactly the way I would leave that answer, folks. All right, now definite increase in difficulty. Here we go. This will be a product rule. I've got 2 x's. It's the first piece times the second piece. I'll divide it right there between the square and the natural log. So if we use the simple rule that I've been using in class, it's the derivative of the first, 8x, times the second, natural log of 4x plus 8, plus the derivative of the second. Okay, here we go. The derivative of the second will be somewhat complicated. I'm just going to underline what I need there. That'll be the derivative of the second times the first, just to kind of help us out. All right, the derivative of the second would be 1 over 4x plus 8, because the derivative of the natural log of anything is 1 over anything. But remember, it's not a simple x, so I can't just leave it. I have to multiply times the derivative of what's inside, which would be a 4. So this is all the derivative of the second times the first, so times my 4x squared. All right, now you can treat that 4x squared like it's over 1 if you want, and this 4, of course, is over 1. So at this point, we'd have 8x natural log of 4x plus 8. That's really nothing you can do with that first piece. Now it's going to get a little bit interesting. If I go ahead and just multiply the numerators together, I have 1 times 4 times 4x squared, which would be 16x squared, all over 4x plus 8. All right, now this was a little bit tricky. You'll notice, of course, I would have given you half credit, by the way, for just getting that far or this far. But you had to notice that all three pieces here were indeed divisible by 4. So I could take the 4 into the 16, 4 into 4, and 4 into 8. 4 goes into 16 4 times, 4 goes into 8 2 times, and of course it goes into the 4 1 time, but 1x is frankly just x. And then you could simply leave the second piece. Well, let me write the first piece first. Now 8x, natural log 4x plus 8, plus, I'm going to have to squeeze it in. I really didn't give you guys quite big enough blanks. My apologies for that. On the top, we're left with a 4x squared. And in the denominator, we have 1x plus 2, or simply just x plus 2. Okay, let's continue on to the next page. Now here we have a quotient rule. And I strongly advise you to go ahead and work it as a quotient rule. Unfortunately, many of you had the quotient rule backwards. I really like my little rhyme that I taught you. Low d high minus high d low all over square of low. And remember, it has to rhyme. A lot of you even wrote that little phrase out, had it backwards, and didn't notice that it didn't rhyme. Low d high minus high d low all over the square of low. So it's low, which would be x plus 2. D high, derivative of high, would be 10x. Minus high, 5x squared plus 10. And for emphasis, I'll just put that in parentheses because it has to be, again, the entire high, or numerator, times the derivative of low, which is a simple 1. And you'll notice I didn't say it, but I did the same thing here. It's low, or the denominator, the entire denominator, times 10x, or times the derivative of the top, all over the denominator squared. Now please notice, of course, half credit for just getting this far, and this again is my derivative. I can't reduce here because I can't take an x plus 2 out of this term. Even if I tried to factor a 5 out, it still doesn't quite work. That'd be an x squared plus 2, close but no cigar. So the only thing I can really do here is simplify my numerator. Taking my 10x through the numerator would give me 10x squared plus 20x. Now, negative, this will be a negative. You can move the 1 out front if you want, but it's just take the negative through the parentheses would make that a negative 5x squared minus 10 all over, of course, x plus 2 squared. And now we just have a couple terms in the numerator that we can combine. We have a 10x squared minus a 5x squared, which would leave me with a 5x squared. And then I still have my plus 20x minus 10 all over the denominator, which I just copy, x plus 2 squared.